Hello everybody, hope you're all well. Sorry it's been a while, been a bit manic this year, hasn't it, last year, what have you. Anyway, I thought we'd do something different today. Going to build a computer from scratch. Well, not from scratch, from a kit. And what is it? What is it? It is going to be a Spectrum clone. So this came from a company called Zelux Renew. It's a remake of the case and the rubber keyboard mat, the shield. So using this kind of frosted or transparent grey case, it could look quite nice. Kit itself comes from a company called backlit, which is in the Netherlands. And what you get a really nice kit with some really nice instructions. So this comes in different versions. So this is obviously the 128K one. That's what it's going to look like, hopefully, without this. And it all comes really nicely packaged. Everything's all labelled and set up for us. So all the little components, and there's all the chips, sockets, and there's the PCB. So it's a 128K Spectrum clone designed to fit in a 48K case. And the key thing about it is it doesn't need a ULA, which is the failure point on Spectrums. It can't be replaced because they don't make them anymore. It uses 74 series logic to replace the ULA. I'm also going to do this. We're going to have a LED keyboard, but instead of the membrane, we've got this kind of PCB keyboard, and it's got LED and resistor places, button places, and diode places. Now I'm not going to do an absolute blow by blow, component by component. What I'm going to probably do is take each point in the manual and then show you me doing it. If I hit anything that's confusing or think needs clarification, I'll elaborate. So this is the board. It's all very nicely labelled where everything goes. Well, I've got running the fume extraction system, D1, D2, D3, D6 and D7. There we go, that's all the resistors on. The only problem I had, or is it down to my own fault, these are resistor packs. They've got a common pin which is marked by the square pin, or the square. See, some of these are square, it's normally pin 1. So yeah, I rushed ahead and put those on before checking, but it is actually written in the manual. So read the manual. Let's kick off with some of the sockets. So I've got first one, 1 dip 8. It's dip 8. It's got 4 on each side. Notch goes on the top. Dip 8 is going to be this guy here. Just put a little bit of blue tack on it just to hold it. I want to turn the board over, one on there like that, and then push it from the other side like that, opposite corner. That's pretty straight. Alright, so that was a bit of a mission. I've done all the sockets. I've done about 3 meters of lead core solder, so I'll definitely use some fume extraction. It was just long-winded. There are quite a few sockets, as you can see there. The only things that really got me here were this chip. This is not really a chip. This is a resistor array. I put the chip on here and then the socket and soldered the sockets to make sure the chip would fit. They cut the bar out, so that's all good. Wondering what these holes are for. Move on to the transistors. Transistors are fairly straightforward. You've got 4 here, 1, 2, 3, 4. They're all the same BC 548s or whatever they are, I think. And then you've got a whole bank of them here which are all the same, and they're labelled. So you can see the base collector and emitter, that's more like it. Put them out, and then bend them in. So they're a bit more like that. I don't know if you can see that, focus. And then they sit lower, because otherwise they're going to sit right up past the tops of the chips. Okay, so that's the transistors on. They're a little bit higgledy-piggledy. You can see I got better as I went along. Kind of go up and then flatten off. These are the later ones. But they're on. So 1, 2, 3, 4. about another 6, 7, 8 there. Next is capacitors. Right, so quick update, got all the caps on, all of the little sort of, what are they called, ceramic caps. I use my own for the 100 nanofarads. Got dip switch on. Next thing that's confusing me a bit, I've got all these jumpers, pin headers and jumpers for ROM select and everything, but looking through the instructions, I think I'm going to leave it default, see what happens at first. And then we've got the crystals, so 2 crystals, Y1 and Y2. Y1 is here and Y2 is here. And then we're going to get down to things like the power connector, the earphone connector, and what have you. Okay, so it's the next day now. Where we've got to now is the keyboard connectors are on, the dip switch for the ROM connectors on. I've opted for a Traco power regulator because I had one here instead of the one that comes with the kit, but you know, I'm sure the one that comes with the kit is fine. You just have to fold it forward on its face like that to make it fit. One other thing, the original Spectrum used to have a center negative power supply, and I can't see on the schematic or on here any reverse polarity protection. On some of my older videos you'll see I put a diode. I just cut the line and put a diode so that you can't reverse volt it. What I might try on this one is to use the technique I showed on the Amstrad with a MOSFET. Don't go and just fishing out any old adapter and plug it in, because it would be the wrong way around. I'm going to put some power into it and just check that it's giving out voltage, and then I'll start populating the board. Okay, so I've soldered in my 2 ROM select jumpers. There's one here which is J18 and there's one here which is J17. What I'm going to be using, a 256k ROM. So this is an M27C 256B by ST Microelectronics. I've got the EEPROM in the EEPROM holder with the notch lined up with where it should be, and the clip down. So what I'm going to do is click program chip, program the chip. Programming successful. I've just gone over it with a magnifying glass just to make sure all the chips are up the right way, and one of them isn't. So it's worth doing that. This one, see, I put it in the wrong way round. It's black board and it's shiny, so that's why I'm tilting it up and down. I want to get the best view. There's one there that I haven't hit that. Plugged in and powered on, and that's what we got. I wasn't expecting nothing else, to be honest. Have to take it back to the kitchen table and see if we can find anything. Okay, just having a little squiz over the back of the board, and that's going to be definitely one problem. One of the pins isn't soldered on. Okay, so this time we've got it on the mat, and this time it works. That's the board done. And the next part is going to be the keyboard. Right, so amazingly enough, the computer works. I've tried a couple of games on it and it's fine. So next stage is a keyboard and a case. And each of these switches has got to be soldered onto the PCB. And each of these diodes as well has got to be soldered onto the PCB. And then optionally, which I'm going to do, LEDs. And obviously resistors as well. It needs 3.3 volt regulator as well, which I'll work out in a minute. And I'm going to start with the LEDs. So we got switch, diode with the negative marked, LED and resistor. If you look at these little tiny LEDs, you'll see a green band on one side, and that's normally the negative. I'm just going to put that on there like that. And get another LED. And I don't want to open more than one at once because they'll just disappear. So there's our LED. So again, I'm holding the board down, so I don't want the board to skate out from under me. Red, yellow, green, blue. There. See the green I was talking about? That's the negative. So So just to quickly test diode mode, negative on the negative and then on the positive of each of these. Boom, boom, boom. There we go, all at work. This is one of the switches. It's like a little push button switch. It's got 2 tabs at the top and 2 tabs at the bottom. So we're going to go for this guy J, which this time is right in the middle of the screen. I'm going to put a little bit of solder on there and get a switch. Make sure that the tabs line up with this. Hold the board down by friction. Try and get as comfortable as possible, and then there you go. There you go. So I'm going to go away and do the rest of them and come back when they're done. So there's 40 of those on. That's the LEDs and the buttons. So next up, we've got to do the diodes. Now the diodes come in the little strip. So the white line, or the black line between 2 white bars is actually the cathode. So this is the diode goes this side where it says diode. And it's going to put a little tin that pad there. And then I want the black line towards the bottom. So like that. There. Tin the other side. And like that. Okay, so there's the diode on. Cathode's the white line at the bottom. Okay, that's all the diodes on. They're all on the right way round. So there you can see a close up. You've got LED, switch and diode, and then the resistor for the LED goes on here. It depends on the colour. So that's going to be a bit of trial and error. Anyway, it's on. Okay, so now it's time for the moment of truth. And there you go. I'll just turn the lights out. And there you go. So that's at 3 volts. Take it up to 3.5. Or down to about 2.5. So I'm going to put a variable voltage regulator. I'll probably leave it at 3. But that's what it's doing underneath. And that's what the LEDs look like. Okay, so trying to put it all together now. Things I've done to it since I last showed you. I've put the jumpers on here because that needs to be on to disable the joystick. And if the joystick's not disabled, the joystick interfaces don't work. So the case is really nice actually. The case, a smoke grey colour. And what's really nice about it is it clips into place and it's not going to rock around in there. And then the top goes on like that. And the screws go all the way through, so they're going to hold the board in. That seems flat. One thing I can't work out, we've got a bit of a curve here. But the actual keyboard seems flat, so that would sit like that. Then we'd have that. Sort of knocking it up, and then that would stick over the top. That's what it's going to look like. I'm just a bit worried about that bent in like that, but I guess if the tape's strong enough that'll be fine. I've been debating whether to power this with a buck converter or a linear regulator. So unless I was to take from the 5 volt and then step down from the 5 volt to the 3.3 volt, I could use a linear regulator. But on balance I think I'm going to use a buck converter because I can change the intensity of the LEDs with this little pot by changing the output voltage, and I can just connect it straight onto the input. I won't have to fanny around going via the 5 volt rail down to 3. So first of all we've got to get power to the keyboard to light up the LEDs. Probably wants to come from underneath. That one. That's it. I'm going to break the main line in here and put a reverse protection on it. So I don't want to connect it here because that would just mean that this would be protected, but that wouldn't. So if I pick it up from here, which just happens to be this pad here, then I can use that. That should be the negative, center negative, sorry. Yeah, that should be the negative, and that should be the positive. Yep, happy with that. There you go, sitting down nicely. Okay, so that's the furthest away it can be from any other component, just in case it's causing switching noise. And that's it. Once it's stuck, that's it. Go in there, power up there, and now I'm just folding back these cables. This is genuine first time power up. I'm reaching for the plug, plugging it in, and there we go. That's not bad at all actually, I'm really chuffed with that. I think it looks great. Okay, so that's a relief, it all works and everything. What I really don't want to do is forget that this is centre pin negative. Go away, fish something out of the loft and plug it in and blow it all up. Skim over this quickly. I did this in the Amstrad video, and actually I nicked it off a guy called Afrotechmods, which I'll link in the description. Previously on these I've just put a diode. I've cut the track that goes for the positive and put a diode in series with it, and that's fine, it's just a bit wasteful. So the Spectrum power supply's got a centre negative pin. This is the line coming in from the Spectrum power supply, so this would be the outside of the Spectrum power supply, that would be the pin, the negative. This is the positive. It comes in and it comes down a track I'll show you on the computer. I'm going to cut that, and I'm going to put this MOSFET in series with that. I'm going to put the drain on the input of it, the source on the output of it, and the gate to ground. And what that will mean is this P-channel MOSFET will only conduct from drain to source, i.e. complete the circuit, if the gate minus the source is less than minus 4 volts. So in normal operation, this is positive 12 volt, so plus 12. This parasitic diode inside the MOSFET is going to drop it by about a volt, so plus 11 and 0 volts, because the gate's tied to ground. So 0 volts less 11 volts minus 11 volts, which is tick, less than or equal to minus 4 volts. Okay, so if it was connected the wrong way around, then suddenly this is positive and this is negative. Right, assuming it was connected, assuming that the MOSFET was conducting, the drain and the source would be the same, because this would be connected, so it'd be like a wire between them. So that's 0 volts, that would mean that's 0 volts, that's 0 volts. And this is tied to 12 volts. For this to be on, this minus this needs to be less than minus 4 volts. Well, 12 minus 0 volts is plus 12 volts. Condition not met, the MOSFET can't be on. Apologies if it's jiggling around a bit, but it's very close up. This is a positive rail. This track here, with the thick one here, carries all the current, the main power in, so I'm going to have to cut that line. Okay, so there's the cut on the power line. That's gone right the way through, and I've checked continuity. Temporarily moved that wire out of the way. I'm just going to cut a bit of verboard and then cut between the gate and the source pins. So there's a soldered MOSFET ready to be put into the Spectrum or Harlequin. Top there, that's the drain. These three are the source, and that's the gate. Because this MOSFET come out of a busted drone ESC, I need to know if it works. So if I put the meter on diode mode, see that? That's the diode drop. So that's the diode between the drain and the source. So if it's doing that, it can't be shorted, because if it was shorted, it would just be showing a wire. It's just got a little bit of double-sided tape on the back of it. So I've also checked that it fits in the case and it's got enough clearance. Okay, and there's my finished handiwork. I didn't show you me doing it because it was quite long and drawn out, but basically the power comes into this pin through the outer barrel of the jack, goes to the drain of the MOSFET, and then the source, so that's like an open switch at the moment. switches between the drain and the source. The source goes on to the regulator, which provides 5 volts to the board, and off to the other regulator, which lights up the backlight, the keyboard. So that switch is effectively open until this MOSFET is activated by the gate, which is this black wire here. And the gate only shuts if the thing is plugged in the right way round. Okay, so please forgive the handheld camera angle. There's not an easy way of doing this. I'm just going to demonstrate the RP protection works. This is a Spectrum power supply center negative. This is a 12 volt power supply center positive. So first of all, I'm going to plug the Spectrum one in. So there you can see happily humming away with the Spectrum power supply. Okay, now we'll try with the center positive 12 volts. So I plugged in the center positive 12 volts. Nothing. We've got some weird behaviour on the power supply. It's cycling like it's shorting. So we go back to the center negative Spectrum power supply, and we're still all good. Okay, well, hopefully you enjoyed that. I'm going to wrap it up here because the video's going on a bit now. And I did do an optional mod which is detailed in the manual, which is you know, a minor thing for some demos. There you can see my reverse polarity protection. But overall, a really nice kit. Enjoy building it. Really well laid out, easy to follow, not a nightmare at all. The case really nice, fits the board really nicely. Goes together really well, quality gear. One minor gripe, and it's probably my fault, I can't get this corner to stick down on the thing, but that happens on the normal ones anyway. It just seems to be a little bit off there. I'm sure a bit more tape will sort that out. But thanks for watching. Take care, hopefully you enjoyed that, stay safe, and I'll see you all soon. Cheers, bye.